Hello and welcome again to FlippedHarber for Algebra 2. In this video we're going to be talking about rational expressions again, but we're going to be taking a look at adding and subtracting these rational expressions. Our objectives for this lesson are to learn how to add rational expressions as well as how to subtract rational expressions. We also want to take a look at how to simplify complex rational expressions. Our outline for the video, we're going to take a look at adding rational expressions that are quote-unquote easy. We're going to take a look at adding rational expressions that are a little more difficult. We're going to take a look at subtracting rational expressions. We're going to take a look at what a complex rational expression is. And then we're going to end by learning how to simplify these complex rational expressions. Now, adding a rational expression literally means that we have to take two fractions and add them together. Now, if you think back to 4th grade, 5th grade, whenever you learned how to add and subtract fractions, the idea of a common denominator should be coming back to you. Now, in this case, because these are rational expressions, we have polynomials as our denominators, but the idea still holds the same. Math does not change. Just because we added some letters to this does not mean we changed our rules. We need a common denominator, a common polynomial, in order to add these two fractions. And lo and behold, this is why this is an easy example. We have that common denominator. That common denominator is the entire thing, x plus 3. So if we want to add these fractions, we're going to basically just go ahead and mush the two numerators, the two tops, together over this common denominator. Now really the only thing left to do is to combine like terms. So here in our easy example, 2 over x plus 3 plus 3x minus 4 over x plus 3. We add them up, they have the common denominator, we combine like terms. We have 3x minus 2 over x plus 3. Okay, so it'd be nice if they all stayed this easy, but you know they're not going to. So let's take a look at an example that's a little more difficult. The reason that it's more difficult is because we don't see this common denominator in both of our fractions. Now, when I'm introducing the idea of adding fractions, even at a really basic level, I don't like this idea of a least common denominator. There's reasons to learn about the least common denominator. I want you to kind of put that out of your head right now. And I want you to think about the easiest common denominator. The easiest common denominator is always our two denominators multiplied together. So that's actually what we're going to do. That ends up being our least common denominator here, but it's our easiest common denominator that we work towards. Our easiest common denominator is x plus 3 times the x minus 2. So when I look at this, I start to look at what does each fraction need to create that easiest common denominator. And in the case of the first fraction, it's got the x plus 3. What it's lacking is the x minus 2. So we're going to multiply by x minus 2 top and bottom. Just like when you were learning how to do this back in 4th grade, 5th grade, whenever, you multiplied by a number top and bottom to get that common denominator. Now we're going to multiply by a polynomial. My second fraction has the x minus 2. It needs the x plus 3. So that's what I multiply by, top and bottom, to get that common denominator. Now, when I multiply these things together, this is what I get for my two rational expressions now. They both have the common denominator, x plus 3 times x minus 2. Now what I need to do is bring them together. So 2x minus 4 plus 3x squared plus 5x minus 12. Well, the 3x squared, there's nothing else to combine with it. The 2x and the 5x can combine. And the minus 4 plus negative 12 can combine. So we have 3x squared plus 7x minus 16 on top. Notice that I have left the bottom factored out. It is always in your best interest to leave rational expressions factored out. The reason I did not leave them factored out in the top is because I needed to combine like terms. Now I could go ahead, try to factor out the top, but I know that there's not going to be anything that cancels out. So I'm going to leave the top the way it is, but I would encourage you to leave rational expressions factored out if you can. You'll see why in future videos. Okay, now subtracting rational expressions. Subtraction is pretty much just like addition, and that's true in this case. Okay, I'm not going to bother showing an easy example. I'm just going to get right into it where we have different denominators in our two rational expressions. The only thing to remember is that this negative right here in between the two rational expressions, that negative goes to both parts of the top of our second rational expression. So that negative needs to go to both the x and the 3. That's probably the most common mistake that I see, is people will go minus the x. That's great, but they'll forget that that minus needs to get distributed into the 3. So let's go ahead and take a look at an example. Okay, we're going to have to create a common denominator. Our easiest common denominator is the two denominators multiplied together. So I think about what each fraction needs in the denominator. That's what I multiply by, top and bottom. And I go ahead, multiply together the two tops on the left side, multiply together the two tops on the right side. Notice these parentheses. These parentheses here serve to remind me that this negative right here goes to all three terms. That's my most common mistake that I see with people, is they forget that that negative goes to all three terms. Leave the bottom factored out. Just combine your like terms on the top. Bada boom, bada bing, you are done. Alright, let's talk about what a complex rational expression is. A complex rational expression has fractions within fractions. Fractions that are in the top, or fractions that are in the bottom, or maybe I got them in both the top and the bottom of my big rational expression. Now, this isn't too big of a pain to deal with if you keep your wits about you. To get rid of fractions, you multiply by the denominator. So if I want to simplify this down, what I need to do is multiply by the small denominator, both top and bottom. Now, what I mean by the small denominator is this x plus 1. And we see that both small denominators are x plus 1. So I'm going to be able to multiply by that x plus 1 on the top and on the bottom of my rational expression, and everything's going to become a whole lot simpler. So, multiply by x plus 1, top and bottom. Looks a little bit messy. I've kind of left it messy to show all the gory details. The gory details here are that when I bring this x plus 1 times this fraction, the x plus 1's cancel right here. Now that just leaves x minus 1 times 1. Now there's nothing to cancel right here, so I'm going to have to multiply that x through and get x squared plus 1. We'll see that in a second. But I do get this x plus 1 to cancel right here as well. Now you'll notice that I carried my x plus 1 through and I multiplied it by both the 3x and the 1. I could do the same thing if I just put the two binomials multiplied by each other. That would get me the exact same thing. If you wanted to look at the 3x plus 1 as one binomial and FOIL it together, that's fine. It's going to get you the exact same answer. Okay, so I cancel things out. I've already talked about what's going to cancel out. Let's take a look at what we end up with. On the top, we have that x minus 1 times, plus that x multiplied in is x squared plus x. On the bottom, we have 3x squared plus 3x plus x plus 1 plus 2. Everything got a whole lot simpler. I don't have any more little fractions inside my rational expression. So now all I've got to do is combine like terms. Now, maybe I should go ahead and try to factor out the top, factor out the bottom, but a lot of times with these things, it's just not going to work Okay, if you can do this for me, if you can get rid of the little fractions, you can combine like terms, stop. That's great. I'm just thrilled to see that. All right, let's do this one more time, but notice, oh no, now we've got another fraction in here, and this little denominator is different from the x plus 1s. So now I'm going to multiply by both x plus 1 and I'm going to multiply by x minus 2, both top and bottom. Now, I've drawn it all out in gory detail. Take a look at what's going to cancel and what's not going to cancel. My x plus 1s will cancel right here. I'm still going to have this x minus 1 times the x minus 2. My x minus 2's are going to cancel right here. I still have to take that x and multiply it by the x plus 1. The 3x plus 1 didn't have anything to cancel, the x plus 1 or the x minus 2. I'm stuck multiplying by all of it. Oh, shoo! But I do get to cancel this x plus 1 with this x plus 1. So let's take a look at what things simplify down to. Okay, so I've gone ahead and I've canceled everything that I can. I still have a lot of multiplying to do. And even now, with all of this multiplying done, I still have to combine like terms. Oh, looks like I'm missing a term, or maybe I just don't need that plus right there. All right, so there we are. It's time for you to try some of these on your own. I'll see you in class, and I'll see you online.